Everything you think you know about our story might only be the last page of a much longer book. Imagine closing your eyes and compressing Earth's entire history into a single day. The planet forms at midnight. Life appears in the morning. Dinosaurs arrive late in the evening, and humans, we slip in during the final flicker before the clock resets. All the cities and signals and stories we call history live in that last second, a spark in the dark. Now, breathe in and tilt the frame. What if the spark you're standing in was never meant to be ours? What if, somewhere just before midnight, the sky never fell? Step back. You know the version we grew up with. An asteroid struck what is now the Yucatan. A shockwave turned forests to glass. Global winter followed, and most dinosaurs except the lineage that became birds were gone. Mammals, small and watchful, flowed into the empty light and multiplied into hooves and paws and hands. One branch learned to shape stone and coax fire, and eventually launch its questions into orbit. That's our tidy arc. It feels inevitable because we're here to tell it. But contingency is a quiet tyrant. If the asteroid misses, even by minutes, the coin flip lands on its edge, and everything after is rewritten. This is not a claim, it's an invitation to think in longer timescales, to notice how many of our certainties are really habits of perspective. Imagine we dim the room. A soft line creeps across the bottom of the screen, the geologic clock. On that clock, dinosaurs are not museum pieces, they are prime time. They dominate ecosystems for over more million years hours of the day. We appear in less than a heartbeat. In a world where the impact never happened, megafauna remain incumbents. Mammals may survive, yes. But do they ascend? Do we? You don't need to force an answer. Let the question sit, like a pebble in your palm. Our best tools here are not ruins or imagined cities, but the logic of ecology and the physics of preservation. The record is not complete. Earth is not a museum, it is a studio that constantly paints over its own canvases. Even our present steel and glass and fiber will compress to a thin chemical line given enough time. So, if we're going to ask whether humans would exist in a world where dinosaurs never left, we'll do it gently, patiently, by testing how living systems respond when niches never open, how intelligence evolves under a long shadow, and how chance keeps its own calendar. First, acknowledge scale. The dinosaurs you picture, the horned faces, the sickle claws, the long-necked architects of the canopy, arrive late in the day, but then stay a very long while. Late Cretaceous seas are warm, shallow waters flood continental interiors, flowering plants explode across landscapes, avian dinosaurs take to the air, mammalian bodies, small and quick, thread through the underbrush and night. Then, in our timeline, a bright line, Chicxulub. But the counterfactual is simpler than it sounds. Remove a single night of fire, and you remove the door it opened. If you've ever wondered why mammal and bird intelligence blooms the way it does, think of empty seats in an auditorium. When mass extinction pulls leaders off the stage, 1,000 auditions begin. Without that purge, incumbents hold the mic. It doesn't mean innovation stops, it means innovation has to happen under, around, or within what already works. In that kind of world, large-bodied dinosaurs remain landlords of the sunlit niches, and mammalian experiments likely stay small, secretive, and specialized. The thread that leads to us might still be there, but frayed, tangled, delayed, or cut. Pause and look down. Under your feet, rock becomes a library with missing pages. Even if a long-lived lineage of thinkers ever stood on different legs and peered at the same sky, the silence of deep time would swallow most of what they were. That's why, in this series, we lean on signals that survive erasure, not statues, chemistry, not cities, cycles. If you want to know whether a civilization existed, and here we're simply borrowing a method, not making a claim, you look for fingerprints the planet can't help recording, carbon isotope oddities, nitrogen imbalances, synthetic residues, metal distributions that don't look like geology's handwriting. We'll arrive at that later. For now, the question before midnight is simpler. If the asteroid missed, would there be room for us? You might feel the answer rising. Probably not, but notice the words you choose. Could, may, perhaps. Evolution is not a script. It's an improvisation played against moving continents and changing climates. Intelligence has emerged many times in quieter keys, corvids, parrots, cetaceans, cephalopods, without hands like ours. Some maniraptoran dinosaurs, close to the line that becomes birds, already show signs we associate with problem solving. It's tempting to imagine a what-if future where grasping forelimbs grow more nimble, where social learning expands, where vocal tracts and syrinxes harmonize into complex signals. It's also tempting to project ourselves forward into that shape. We should be careful. The past owes us no resemblance. If you step back even further, the heart of this episode isn't an answer but a posture, humility before contingency. The impact that erased the dinosaurs as we know them is not just a dramatic chapter break. It is the pivot that gives our branch room to fan out. Remove it, and you remove the ecological lottery that mammals won. Leave it out long enough, and you ask evolution to find a new route to minds that plan and hands that write. It might. Given millions of years, life often tries similar moves, or it might prefer different solutions entirely: flocks over families, beaks over thumbs, chorus over syntax. We can sketch possibilities, but we should whisper them. So tonight, as the ambient bed settles and the screen darkens to a slow pan through stars and strata, hold two thoughts at once. First, that our presence may hang on a single cosmic miss or hit. Second, that Earth contains many ways to be clever, many ways to inhabit a mind. The record is not complete. We'll spend the next chapters walking the late Cretaceous shoreline that never flood-cooled, listening for how ecosystems behave when incumbents never yield, and asking, softly, in a world where dinosaurs never left the stage, would humans ever be invited on? Imagine the geologic clock again, a quiet circle with pale bands for oceans and darker arcs for continents that come and go. If midnight is Earth's birth, and noon is the first forests, then by 10 at night the world hums with dinosaurs' horned faces in floodplains, long-necked browsers moving like living cranes, sickle-clawed hunters flicking through fern shadows. Flowering plants expand, insects glitter in the warmth, shallow epicontinental seas lace the continents, and the air itself carries more heat than we're used to. Mammals are present quick, sharp, mostly small, threading their lives through niches the giants ignore. On our clock, all of that is steady evening. Then, in our timeline, there's a bang you can't paint on a clock face, a brief, catastrophic flip between seconds. We call it the KPG boundary. It is a knife line in stone. Step closer, gently. In what is today the Yucatan, an object roughly 10 kilometers across knifes into shallow sea. In an instant, the sky turns to fire and glass. Shockwaves race across the crust, forests ignite continent-wide, ejecta rains down, sulfur-rich aerosols bloom in the stratosphere, and sunlight dims for months. Food webs that depend on photosynthesis buckle. On land, anything big, slow to reproduce, or specialized is punished first. In the sea, the plankton at the base of the ladder falter, and the rungs above them loosen and drop. Within what feels like the deep time equivalent of a held breath, most non-avian dinosaurs vanish. So do giant marine reptiles, ammonites, and a braided tangle of lineages we know mostly by their absence. In our world, that sudden vacancy is the very space mammals expand into. Now, turn the page to the counterfactual and quietly remove the impact. No shockwave, no global blackout, no instant scything of the food web. The late Cretaceous keeps unspooling. The seas remain warm. The coastal plains stay rich. Forests keep their canopies. Birds, the dinosaurs that fly, keep evolving in their own direction. The incumbency of large-bodied dinosaurs continues without an enforced intermission, and the most important rule in macroevolution clicks in. When the stage isn't cleared, the actors already on it keep the best lines. This is the part that can feel counterintuitive if you're used to thinking of evolution as a ladder climbing toward us. It isn't. It's closer to a braided river, channels splitting and rejoining, some cutting deep, others filling with sand. Mass extinctions behave like sudden avulsions, river captures that shove water into a new course. Without the KPG pulse, the river doesn't jump, it meanders on. That doesn't mean stagnation. It means innovation tends to be incremental, nested within the outlines of what already dominates. Where giants hold the open, sunlit niches, day-active herbivores and apex predators, smaller creatures, including most mammals, continue to specialize at the margins. Nocturnal insectivores, burrowers, climbers, omnivores that make a living in edges and understories. The upgrades that matter: bigger bodies, longer childhoods, more elaborate social learning, become harder purchases when someone else already occupies the house. You can visualize it. A late Cretaceous valley that never resets. Herds of hadrosaurs move like living rivers on their own migration schedules. Ceratopsians browse in open galleries of conifers and angiosperms. Theropods shadow the herds, some swift, some heavy, some clever in the narrow ways predators have always been clever. Above them, toothed birds and early modern birds share the air. At night, eyeshine betrays a web of small lives: mammals, lizards, frogs, beetles. In our world, a line from that nocturnal web becomes primates, and a line from primates becomes us. In a world without the impact, that thread may remain, but it likely stays a fine thread for a very long time. Hold on to the refrain: the record is not complete. We're reconstructing paths from fragments, a tooth here, a feather impression there, a mudstone full of pollen. Even so, ecology gives us a few hard-leaning hints. One is incumbency effects. Once a clade fills a suite of niches, it exerts pressure that reduces the probability of a newcomer displacing it without a large disturbance. Another is ecological release, the burst of diversification that follows when incumbents are removed. Our mammalian explosion after the KPG is a textbook case of release. The inverse is sobering. Without the release, the run-up to large-brained primates with long childhoods and fine manipulation may be delayed, diverted, or foreclosed. Notice the verbs may, could, perhaps. This is hedged confidence. not caution for its own sake, but because deep time teaches it. Dinosaurs themselves are not an emblem of simplicity. Many groups were already highly specialized by the late Cretaceous. Some small maniraptorans, cousins to the birds, show forelimbs capable of grasping and brains with relatively high encephalization for their size. Avian dinosaurs, the birds were exploding into new forms. Intelligence, in softer keys, was present across the tree of life. If the sky never fell, it is plausible that cleverness keeps evolving in multiple places. But cleverness is not the same as becoming us. The path to stone tools, controlled fire, and language-rich culture seems to require a particular bundle: fine manipulation, cooperative life histories, extended learning periods, and access to reliable, dense calories. That bundle can be assembled in more than one way. Whether it assembles quickly or at all under a long, unbroken dinosaurian incumbency is the question we're asking. Here's another layer of context that helps situate the coin flip. The impact wasn't the only source of stress at the time. Volcanism was active in what we now call the Deccan Traps. Sea levels were changing, climates were in motion. It is possible, some argue, that ecosystems were already strained, and the asteroid was the coup de grace. Our counterfactual doesn't need to erase every stressor to ask its question. It only removes the most abrupt, global purge. Without that, lineages that would have been clipped likely persist long enough to innovate further. Horned dinosaurs continue to diversify their ornaments. Duckbills refine their dental batteries. Predators explore new tactics. Birds, already learning the sky, keep experimenting with beaks, songs, and sociality. Mammals, still present, still adaptive, might find a handful of mid-sized lanes in forests and coasts, but the giant herbivore and apex predator rungs remain loudly taken. This is where timescale matters. Without a reset, mammals don't necessarily disappear. They simply have fewer wide, sunlit rungs to climb. Given tens of millions of years, they could still produce larger forms in sheltered regions or isolated continents. Evolution is persistent. But every decade, every century, every million-year interval in which dinosaurs keep incumbency is time in which primates diurnal, visually oriented, gradually enlarging their social brains may not get their long daylight experiment. A different experiment could take its place. Intelligent parrots with tool traditions, cooperative seabirds specializing in kelp forest engineering, theropods with more articulate forelimbs developing object manipulation. These sketches are not predictions. They are reminders that the set of possible minds is larger than the set of minds we've met. If you're listening for a verdict, we're not there yet. The next steps are to follow the logic forward. What does incumbency do to innovation? How do climates and coastlines shape the availability of energy? Which anatomical constraints matter most for the ladder of technology? We'll run those checks gently, with our repeated anchor. Absent a global purge, the river of life meanders instead of jumping banks. That tends to keep big bodies in charge of big daylight jobs. It tends to keep the rest in the margins. And it tends, though not with certainty, to make a species exactly like us less likely on this timetable. Before we move on, place a fingertip on the thin clay line that marks the KPG in real rocks, the one rich in shocked minerals and extraterrestrial elements, the one that tells you a night of fire really did pass over this world. That clay is a page turn. Our question asks you to imagine a book without that torn leaf. The story keeps going. But it is not our story, not yet, and perhaps not at all. Close your eyes for a moment and imagine the curtain never dropping at the end of the Cretaceous. The stage lights stay warm, the players remain in motion. The asteroid misses, the seas continue their rhythm, forests keep flowering, and the great herds still thunder across plains of ferns and cycads. What emerges is not stasis, but continuity. A world where the late Cretaceous rolls seamlessly into the Paleogene without interruption. Ecology under that scenario bends around one central fact: incumbency. The ecological chairs are still filled. Herds of hadrosaurs still grind plants with elaborate dental batteries. Ceratopsians still dominate open country browsing. Sauropods in some regions still stretch their necks toward high canopies. Apex predators, tyrannosaurids, abelosaurids, and smaller, faster theropods continue to enforce ceilings on herbivore populations. Avian dinosaurs claim the skies with increasing diversity, filling niches from shorelines to forests. Reptiles, amphibians, and invertebrates weave through the lower tiers of the web. In our history, the impact was like a reset button, emptying most of those chairs. Mammals rushed in, diversified, and occupied roles once denied them. Without that purge, the script is different. Mammals stay mostly in the shadows, confined to nocturnal or marginal niches. A few might push upward in size and diet, but every attempt meets the reality that a larger, more established competitor is already there. Competitive exclusion, the principle that two species cannot indefinitely occupy the same niche, keeps them small, nimble, and specialized. Picture an alternate Paleogene, where the forests still hum with dinosaur calls. Instead of ungulates emerging, you'd see mid-sized herbivorous ornithopods, perhaps smaller ceratopsians, adapted to denser vegetation. Instead of saber-toothed cats, predatory niches might be held by swift, bird-like theropods with sharper senses and more refined hunting strategies. Instead of whales evolving from land mammals, you might find marine reptiles, ichthyosaur-like forms reinvented, re-exploring the open seas. Would this world stagnate? Not at all. Evolution doesn't freeze. Dinosaurs were already highly diverse and experimenting with forms, diets, and behaviors. Given another 66 million years, new branches would sprout. Novel predators, novel herbivores, avians, more sophisticated in cognition and song. But here's the point: the direction of innovation would remain skewed by who holds the power at the top. Large-bodied dinosaurs would continue to dominate the most energy-rich niches. Mammals might nibble around the edges, but wouldn't have the ecological breathing room to stage the explosive radiation that eventually led to primates, apes, and us. Now, step back. If ecosystems keep their incumbents, what does that mean for intelligence? Innovation is possible, but the shape of it could be profoundly different. Imagine ecosystems where the brightest sparks of cognition come not from primates, but from certain bird-like dinosaurs, perhaps close cousins of crows or parrots, developing elaborate social systems and tool use while remaining small-bodied. Or picture mid-sized theropods evolving more dexterous forelimbs, experimenting with object manipulation in ways mammals never attempted. This is where the thought experiment hums. Without the sky falling, the story of cleverness might still unfold, but it likely unfolds without us. The creatures who inherit the open daylight, who scale up in body size and intelligence, would not be mammals. They'd be the heirs of the dinosaur dynasty, the long incumbents of Earth's ecological throne. And yet remember the refrain, the record is not complete. Life improvises endlessly, and contingency can surprise us. Perhaps some mammals still find isolated corners an island, a continent cut off that allows them to experiment in peace. Perhaps from those shadows, even under dinosaurian dominance, a new primate lineage eventually emerges. But if so, it would be late, rare, and profoundly altered from the story we know. So when you ask what Earth might look like if the asteroid never struck, picture continuity more than revolution. Dinosaurs carrying their dominion forward, mammals biding their time, and the tapestry of life weaving a pattern recognizable in some threads but alien in its overall design. The sky never fell, the curtains never closed, and in that alternate ecology, the question grows sharper. If the dinosaurs never left the stage, would the spotlight of intelligence ever shift to us at all? Lean in. The stage is crowded with giants, but intelligence is not the sole property of mammals. Even in our own world, cleverness blooms in parallel. Corvids solve puzzles, parrots learn words, dolphins invent games, octopuses open jars. Intelligence has many evolutionary roots. So in a dinosaur-dominated Earth, the question is not whether minds could arise, it's which lineage would carry them. One group often cited are the troodontids, small, bird-like theropods of the late Cretaceous. Their brains, relative to body size, were among the largest of any non-avian dinosaur. They had forward-facing eyes, grasping hands, and complex teeth suited for varied diets. Dale Russell, a paleontologist in the 1980 seconds, once speculated about their future in an alternate world. He coined the Dinosauroid, a thought experiment imagining a humanoid-like descendant, but critics warned of anthropomorphism. Evolution does not aim toward human forms. If troodontids kept evolving, their intelligence might not look like ours at all. A second candidate, avian dinosaurs, the birds. Already by the late Cretaceous, they were diversifying rapidly. Today's crows, ravens, and parrots show planning, tool use, even cultural traditions passed down generations. Extend that evolutionary trajectory across 66 million years of uninterrupted opportunity, and it's possible that birds could have scaled their intelligence into realms we only associate with primates. Imagine corvid societies not limited to beak and claw, but to complex cooperation, memory, and communication, flocks as nations, songs as libraries. But cognition is not enough. A mind must also manipulate its world. Here lies a constraint. Most dinosaurs had forelimbs adapted for locomotion, balance, or flight, not fine-tuned dexterity. Birds today use beaks and feet in impressive ways, but lack the precise manipulation of a primate's opposable thumb. Without such tools, could technology, fire, weaving, metalwork ever begin? Some say no. Others note that evolution often repurposes structures. A claw could become a grasper, a beak could evolve finer control. Even collective intelligence, distributed across groups, could compensate. Another hurdle is energy. Brains are expensive organs. They require steady, calorie-dense diets. Mammals gained an advantage with fire and cooking, which softened food and made energy more accessible. Without fire, could large-brained dinosaurs sustain themselves? Perhaps through new diets, cooperative hunting, or even symbiosis we cannot imagine. Intelligence has emerged independently many times, cephalopods, cetaceans, birds, yet in most cases it plateaued short of building technology. The reasons are partly ecological, why invest in tools if your niche doesn't demand it, and partly anatomical, no hands, no fire. Dinosaurs might have followed similar paths, clever, social, communicative, but never industrial, and still notice the hedges, may, could, perhaps. Evolution improvises. In our history, it assembled the package we call human from primates. In another, it might have assembled something equally strange and wondrous from saurian stock. A lineage of intelligent dinosaurs, shaped by pressures we can't model, could have gazed at the stars long before we did. If the asteroid missed, mammals likely stayed in the shadows. But intelligence? That spark could still have flickered, perhaps in feathered hunters, perhaps in the skies with birds, perhaps in ways our imaginations struggle to sketch. The record is not complete. And so the question lingers. In a dinosaur-ruled Earth, could intelligence have risen without us? And if it did, would we even recognize it as such? Picture it. The asteroid never strikes. The Cretaceous closes, and the dinosaurs stride into the Paleogene unchallenged. What of us? What of mammals? For 150 million years, mammals lived in the shadows. Most were small, nocturnal, insect eaters, rarely exceeding the size of a badger. Their opportunities came only in the brief ecological gaps left by dinosaur dominance. Without the asteroid's reset, those gaps would have closed. Dinosaurs would have continued to dominate every major niche. Apex predators, grazers, flyers, even the oceans. Mammals might have persisted as marginal players, tiny burrowers, night foragers, opportunistic scavengers, intelligent primates? Probably never. Our branch would have remained a footnote, overshadowed by reptilian titans. Think of what vanishes in that scenario. No primates climbing into trees, no apes evolving grasping hands, no hominins shaping stone, no humans carving history. Fire, language, agriculture, none of it unfolds. The great human story never begins. Instead, ecosystems remain reptilian at their core. Gigantic herbivores reshape forests. Predatory theropods refine their strategies. Perhaps avian dinosaurs diversify into roles birds never reached in our timeline. Mammals, if they survive at all, remain small, secretive, peripheral. This is the humbling lesson. Our existence depended not only on evolution's slow improvisation, but on one sudden catastrophe. A single rock from space determined whether mammals would inherit the Earth or remain forever insignificant. We often see ourselves as inevitable, as though the march from fish to humans was destiny. But in truth, it was luck. Without the asteroid, the mammals never ascend, and without their ascent, the human story never begins. So, when we ask, what if dinosaurs never went extinct? We are also asking, what if humans never existed? We are asking whether Earth would still have intelligence, still have civilization, but in forms alien to us. And we are reminded that history is fragile, written in chance and erasure. If dinosaurs had not fallen to the asteroid, what shape could intelligence and even civilization have taken on Earth? Some lineages were already on an evolutionary trajectory toward bigger brains. Troodontid small, bird-like predators had high encephalization quotients, brain-to-body ratios, large eyes, and grasping hands. Give them another 60 million years without interruption, and their descendants might have developed even greater cognitive complexity. Instead of primates, perhaps troodontid descendants became tool makers, hunters with language like calls, social hierarchies, and long memories. They might have been the reptilian equivalent of corvids and primates combined. If such beings had crossed the threshold to civilization, their world would not resemble ours. Imagine cities designed not for mammals but for reptiles, warm-blooded in part, but still tied to the Sunday. Architecture might sprawl outward instead of upward, maximizing exposure to warmth. Materials could be bone, shell, or hardened clay, shaped to withstand heat. Their culture would be shaped by different senses: sharper vision in twilight, greater sensitivity to movement, and perhaps color signaling instead of spoken words. Communication might blend vocalizations with skin patterns, language written on the body. Would reptilian intelligence reach metal and fire? Possibly, but the path might diverge. Dinosaurs had claws, talons, and beaks, but not fine, grasping hands like primates. Tools could evolve from extensions of claws, crafted harnesses, binding, or even bioengineered symbiosis with other creatures. Fire might be less central, replaced by harnessing of solar heat or geothermal vents. If such a civilization had risen 60 million years ago, where might they be now? Could they have reached the stars before humans existed? If so, traces might lie hidden not in fossils but in chemical fingerprints, isotopic anomalies, or even artifacts buried beyond recognition. Or perhaps they destroyed themselves long before mammals inherited the Earth, another cycle lost to time. The question is not just what if dinosaurs had become intelligent. It is also what if humans are not unique. Intelligence may not be a singular miracle, but a recurring pattern emerging, vanishing, and emerging again. In this light, we see ourselves differently. We are not inevitable, not permanent. We are one branch in a tangled history of experiments. Perhaps we are only the latest, not the last. Across human cultures, long before paleontology or geology existed, there were stories of worlds that rose and fell, civilizations that flourished and then disappeared. These myths are not scientific records, but they are cultural echoes, reflections of a deep intuition that permanence is an illusion and that time itself may be cyclical. Imagine standing in the ruins of an ancient city, a place where walls crumble under vines and roads vanish under sand. For people living thousands of years ago, the sight of abandoned stone must have seemed mysterious. If these ruins exist, they reasoned, then perhaps earlier ages of humanity must have flourished, only to vanish. Without fossils, without isotopes, myth became the tool for filling the silence of the past. The Greeks envisioned 5 ages: golden, silver, bronze, heroic, and iron. Each age declined from the one before, each ending in collapse. In Hesiod's telling, humanity was not a single story, but a sequence of chapters, each erased to make room for the next. In Hindu cosmology, time unfolds in yugas, vast cycles so long that they rival the timelines of geology. Each cycle carries growth, decline, and destruction, only to be followed by renewal. To think in yugas is to imagine civilizations rising not once, but endlessly, across spans of millions of years. The Norse described Ragnarok, the twilight of the gods, when fire and frost would destroy the world. But they also believed in rebirth. From the ashes, a new earth would emerge, green and fertile, ready to be lived upon again. In Mesoamerican traditions, the Maya and Aztecs spoke of suns or ages, each one destroyed in turn, first by jaguars, then by hurricanes, then by fire, then by flood. Our present world, they believed, was not the first but the fifth, and like the others, it too would one day fall. Even far from Eurasia, the theme echoes. In Polynesian traditions, the sea itself was a cycle of creation and destruction, islands rising and vanishing, as if the ocean were breathing in and out. Aboriginal Dreamtime stories in Australia describe ancestral beings who destroyed older worlds and remade them anew, leaving the land marked with scars that still shape the landscape today. And in Mesopotamia, the Epic of Gilgamesh described a flood that destroyed nearly all of humanity, sparing only one survivor to begin again. This story, retold in the Bible as the flood of Genesis, reflects a truth recognized across continents. Civilizations are fragile, and worlds can be washed away in an instant. In Polynesian traditions, the sea itself was a cycle of creation and destruction, islands rising and vanishing as if the ocean were breathing in and out. Aboriginal Dreamtime stories in Australia describe ancestral beings who destroyed older worlds and remade them anew, leaving the land marked with scars that still shape the landscape today. And in Mesopotamia, the Epic of Gilgamesh described a flood that destroyed nearly all of humanity, sparing only one survivor to begin again. This story, retold in the Bible as the flood of Genesis, reflects a truth recognized across continents. Civilizations are fragile, and worlds can be washed away in an instant. What makes these myths so striking is how closely they mirror the realities of deep time. Earth has indeed been through cycles of destruction and renewal. Mass extinctions wiped away whole lineages, clearing the stage for new life. Ice ages advanced and retreated, reshaping the climate. Atmospheric oxygen rose and fell, changing what kinds of creatures could survive. Continents drifted, collided, and tore apart, rewriting the map again and again. The Greeks imagined ages of humanity. Geologists see ages of the Earth itself: Permian, Triassic, Cretaceous, each ending, each replaced. The Maya envisioned suns destroyed and remade. Paleontology shows us ecosystems destroyed and reborn. Hindu cosmology speaks of endless yugas. Science describes cycles of supercontinents like Pangaea, Rodinia, and Gondwana, each one formed, broken apart, and scattered. In myth, floods cleansed the world. In science, the oceans themselves erased the past, subducting seafloors into the mantle. In myth, fire consumed civilizations. In science, firestorms followed, asteroid impacts, and lava from the Siberian traps smothered life across whole continents. The parallels are not evidence, but resonance. Myth told in metaphor what geology later confirmed: that Earth does not stand still, and that what exists now is not guaranteed to last. Hindu cosmology speaks of endless yugas. Science describes cycles of supercontinents like Pangaea, Rodinia, and Gondwana, each one formed, broken apart, and scattered. In myth, floods cleansed the world. In science, the oceans themselves erased the past, subducting seafloors into the mantle. In myth, fire consumed civilization. In science, firestorms followed asteroid impacts, and lava from the Siberian traps smothered life across whole continents. Think of Earth's history as a library. The fossil record is like a handful of surviving pages. Myth is the story humanity told to fill the missing chapters. A flood legend is a way of explaining ruins swept away. A cycle of ages is a way of imagining why permanence feels so fragile. Both myth and science point to the same truth: the record is not complete. And perhaps this is why the idea of civilizations before the dinosaurs feels both scientific and mythic at once. Science asks, could intelligence have arisen, been erased, and left behind subtle traces? Myth whispers, many worlds came before, many will come after. This perspective is humbling. It reminds us that humanity is not the first to imagine permanence, and we may not be the last to lose it. Civilizations rise, they fall, and time erases almost everything. Myths captured this intuition in symbolic form. Science explores it through evidence and rock. Both speak the same underlying message. What we see is only a fragment of a much larger story. So when we ask, what if dinosaurs had never gone extinct? Would humans exist? We are also asking a deeper question. What cycles have already passed that we will never know? The myths answer with stories, the rocks answer with silence. The record is not complete. It may never be complete. But in myths and in science alike, we glimpse the same haunting pattern. Worlds rise, worlds fall, and memory is fragile. When people imagine history, they often picture ruins that endure. Pyramids rising from the desert, temples carved in stone, walls standing for thousands of years. But on the scale of deep time, even stone is temporary. The earth does not preserve with care. It erases, it recycles, it begins again. Rain falls, rivers carve, wind wears down. Mountains rise, only to crumble grain by grain into valleys. The Grand Canyon is a scar that reveals layers of time, each band of rock a page in the story. But most landscapes are not preserved like this. They are ground down, smoothed out, their details lost. A city built today, if abandoned, might be recognizable in a few centuries. In a few thousand years, it becomes dust. In a few million, even that dust may be swept away by water or buried under sediments. Beneath our feet, continents drift. They crash together to form supercontinents like Pangaea, then pull apart to form oceans. Seafloor spreads outward, carrying sediments with it, until it vanishes into subduction zones, pulled deep into the mantle. Most of the ocean floor is younger than the last dinosaurs, less than 200 million years old. Everything older has already been swallowed, melted, and forgotten. Continental crust is older, but not immune. Even billion-year-old rocks are fractured, metamorphosed, and reshaped. Evidence within them becomes blurred. What once might have been a fossil can become a streak of minerals, its shape erased by heat and pressure. A civilization written on the surface of that crust would be no more permanent than words drawn on sand before the tide. When sediments are buried, their minerals change. Limestone becomes marble, shale becomes slate. In the process, fossils are crushed, structures warped, chemistry altered. What was once a record becomes a palimpsest rewritten, unreadable. Even the strongest stone is not immune to this transformation. The ocean is vast, but it is not an archive, it is a shredder. Sediments accumulate slowly, then are buried, compacted, subducted, and erased. The continents carry scraps of older pages, but the oceans constantly turn their own pages blank. If there were civilizations on ancient coastlines, their traces are almost certainly gone, dragged beneath the waves and consumed by the planet's machinery. This is why Earth's history feels like a library with missing volumes. We do not read a continuous story, we read fragments, a trilobite here, a fern impression there, a sudden spike in isotopes. Most of the shelves are bare. Whole chapters, hundreds of millions of years, are gone without explanation. The Earth is not a careful archivist, it is an artist, constantly repainting her canvas. Each new layer of rock covers the one before, each mountain range replaces an older one, each ocean floor is reborn. What survives is chance, what is lost is nearly everything. If a civilization had existed before the dinosaurs, or even alongside them, what chance would it have against such forces? Its roads would erode, its buildings would collapse, its metals would corrode. Sediments would bury its cities. Over millions of years, those sediments would turn to stone. Over hundreds of millions, the stone itself would be pulled into the mantle, melted, and remade into magma. Even without catastrophe, the erasure would be nearly total. Time itself is enough. As you picture this, imagine a slow zoom through the layers of rock, strata upon strata, colors shifting from red desert sandstones to grey limestones to black shales. Each layer is a page, each one a chapter, but the book is incomplete. Most of it is gone. The silence of deep time is not a mystery to solve. It is the rule of Earth's geology. So when we ask what remains of ancient worlds, the answer is sobering. Almost nothing. The Earth remembers in fragments, in hints, in scars that only whisper. The rest is lost. The record is not complete. It may never be complete. But in this incompleteness lies the humility of perspective. To know that our civilization too will one day be erased, folded back into stone, and forgotten by the surface of the world. From time to time, reports surface of anomalies that seem to hint at something extraordinary. A tool-like impression in stone, far older than humans. A metallic sphere recovered from ancient strata. Layers of rock showing sudden spikes in carbon or heavy metals that do not fit obvious volcanic or impact events. At first glance, these suggest tantalizing possibilities out of place, artifacts, whispers of civilizations lost to time. But anomalies are treacherous. Many supposed artifacts dissolve under scrutiny. A nail in coal turns out to be contamination from a modern mine. A gear embedded in rock proves to be a natural concretion. Unusual fossils are often the result of erosion or misinterpretation. Even geochemical spikes, which at first appear artificial, can be produced by natural processes, massive volcanism, methane release, or the aftershocks of asteroid strikes. This is why science insists on rigor. An anomaly by itself is not enough. To count, the finding must be reproducible, detected independently, not just once. Its context must be intact, verified, to originate from the layer it is claimed to, undisturbed by later intrusion. And ideally, it must align across multiple proxies, isotopes, sediments, fossil evidence, all pointing to the same story. Only then does a clue rise above the noise of nature's creativity. Without these safeguards, we risk chasing illusions, patterns that dissolve the moment we look closer. And so the promise is this: if we test the idea of vanished civilizations, we will not do it through ruins or legends. We will do it through chemistry, through the subtle markers the Earth preserves, even when everything else is gone. The real search does not begin in the myths or in the museums, but in the rocks. When we look back into human history, long before science gave us the language of geology or paleontology, we find another way that people tried to make sense of the vastness of time. They told stories, Myths, epics, and oral traditions all attempted to explain why ruins existed, why floods swept away whole villages, why fire devoured forests, or why the stars seemed eternal while human life was fragile. These stories are not evidence of forgotten civilizations in the geological sense. They are not fossils or isotopes, but they are cultural echoes, fragments of how humans sensed that the world might have held lives and histories before their own. Imagine standing among ruins in the ancient world, a collapsed city wall swallowed by vines, a river carving through what was once farmland, a coastline littered with broken stone. For those without the science of deep time, the obvious explanation was that another world must have come before, a world that fell to catastrophe. The myth was born not as proof, but as interpretation, a way of giving shape to the silence that surrounded them. The Greeks told of 5 ages: the golden, silver, bronze, heroic, and iron. In Hesiod's vision, each age declined from the one before, ending in collapse. Humanity, he suggested, had lived many lives already, each one swept away to make room for the next. In Hindu cosmology, time itself unfolds in unimaginably long cycles called yugas. Entire universes emerge, grow old, collapse, and then are renewed. To think in yugas is to think in spans that rival geology, millions upon millions of years compressed into repeating arcs. In Norse mythology, the cosmos itself is cyclical. Ragnarok is not just an end, but also a beginning. Gods and giants perish, the world burns, but from the ashes a new earth arises. The Maya and Aztec traditions also describe successive worlds. In some accounts, 4 or 5 previous suns existed before the present age. Each ended violently in flood, in fire, in darkness. Humanity, they believed, was not unique, but one version in a long sequence of attempts. Other cultures echo the same refrain. In Chinese mythology, dynasties of gods and primordial rulers lived in remote antiquity before the current human order began. In Aboriginal Dreamtime stories, the land itself remembers ancestral beings who shaped and destroyed earlier worlds. In Polynesian traditions, cycles of creation and destruction unfold across the ocean, with islands rising and falling in mythic rhythm. Even the biblical flood, rooted in Mesopotamian stories like the Epic of Gilgamesh, carries the same pattern. A world cleansed, a story reset, a small remnant carried forward into a new chapter. None of these stories are geological evidence. They are not testable records of civilizations before the dinosaurs. But what is striking is how widespread the intuition island, across cultures that never met, across continents separated by oceans, humans imagined worlds before their own. They sensed the fragility of permanence. They looked at ruins, or at the scars left by floods and volcanic eruptions, and concluded that earlier ages must have ended. In this way, myths are mirrors. They reflect how people experienced loss, destruction, and renewal in their own time, and they project those patterns into the deep past. They are not accurate timelines, but they rhyme with what science later confirmed, that Earth has indeed been through cycles of mass extinction and renewal. The mythmakers could not know about the end Permian or the Cretaceous impact, but they grasped the deeper truth that life is not permanent, that worlds can vanish, and that stories can be erased. Think of the fossil record as a library, with most of its volumes missing. Myth, in its own way, tries to fill the gaps. It invents missing pages, creates stories to explain why the shelves are empty. A flood story is a way of saying, we know something came before us, but it is gone, washed away. A cycle of ages is a way of saying, this world is not the only world, and ours too will pass. Science, of course, draws the boundary. Myths may resonate, but they are not evidence. They inspire, but they do not prove. To conflate them with geology is to mistake metaphor for measurement, yet dismissing them entirely also misses the point. For thousands of years, humans sensed the incompleteness of history. They knew, in their own symbolic language, that what they could see was only a fragment of a much larger story. This is why the question of civilizations before the dinosaurs feels oddly familiar. It belongs not just to laboratories and rock hammers, but also to the long lineage of human imagination. The myth of Atlantis, though far younger than dinosaurs, is another echo, an island civilization rising to greatness, then swallowed by the sea. The detail is legend, but the theme is universal. Greatness does not last, and memory is fragile. When modern science speaks of deep time, of missing pages and erased histories, it is in a sense rediscovering what myth has always whispered. The difference is that science asks for evidence reproducible, contextual, verifiable. Myth offers meaning instead, helping us live with the knowledge that all things pass. And so, when we listen to these stories, we should not take them as geological records. We should take them as cultural echoes of the same awareness that drives us today, that we are temporary, that history is fragile, and that what came before may be gone beyond recall. Myth is not proof, but it is resonance. It hums at the same frequency as deep time. As you imagine these myths, the golden ages, the floods, the fires, let them blend with the scientific picture of mass extinctions and geological resets. Both tell us the same thing in different languages. Permanence is an illusion. The Earth has carried many worlds already, and it will carry many more. Our own is just one chapter, fleeting, fragile, extraordinary in its moment. The record is not complete. It may never be complete. But in myths and in rocks alike, we are reminded of the same truth. Civilizations rise, they fall, and the Earth endures. Imagine a world where the asteroid never struck. No sudden firestorms, no years of global darkness, no collapse of ecosystems at the boundary we call the KPG. Dinosaurs, flying reptiles, and ammonites continue their reign. The question is not only whether mammals would have remained in the shadows, but how the climate itself would have unfolded, and how those conditions might have shaped the possibilities for intelligence, for technology, for civilization. The late Cretaceous was a greenhouse interval. Carbon dioxide levels were high, ice caps absent, and global temperatures several degrees warmer than today. Without the reset of the KPG impact, many scientists suggest this greenhouse climate might have continued well into the Paleogene. Sea levels were already elevated, drowning much of the continental interiors beneath shallow epicontinental seas. Vast inland waterways crisscrossed North America. Europe was a scatter of islands. Tropical and subtropical forests stretched almost to the poles. Without the impact, the planet might have remained in this lush, warm equilibrium far longer. No sudden cooling to reset the system. No collapse of the marine food chain. Instead, coastlines would have continued to creep inland, and shallow seas would have covered enormous portions of today's continents. A world dominated by shallow seas would have shaped evolution differently. Rich in nutrients, these environments foster biodiversity. Mangrove-like swamps and estuaries would have spread along coastlines. Coral reefs might have expanded across vast, shallow shelves, creating intricate ecosystems. But these same conditions could also limit the pathways to technology. Fire, for example, is a key ingredient in human development, enabling cooking, metallurgy, and eventually industry. In a world dominated by humid wetlands and dense forests, fire is harder to sustain. A civilization arising here might have to invent technology without fire as its foundation, or rely on rare dry zones and volcanic landscapes as their forges. Without the asteroid impact, the dominance of angiosperms flowering plants would still have continued, but perhaps on a slower trajectory. Gymnosperms like conifers and cycads might have retained a stronger ecological presence. The mix of vegetation would have influenced herbivorous dinosaurs, shaping their digestive strategies and indirectly influencing predator-prey dynamics. Energy sources also matter. Humanity's path to industry depended on dense, combustible fossil fuels, coal formed from carboniferous forests, petroleum trapped in sediments. In a prolonged greenhouse Earth, the distribution of these reserves might have been different. More shallow seas could mean thicker marine deposits rich in organic matter. Over tens of millions of years, these could have become vast petroleum reserves, fuel for a civilization that learned to extract them. The absence of the KPG impact means ecosystems continue without the great vacuum left by dinosaur extinction. Mammals remain small and nocturnal. Dinosaurs retain dominance across land, air, and even marginal seas. The distribution of continents also matters. Without the cooling pulse after the impact, polar regions may have remained ice-free for much longer, offering habitable forests at high latitudes. North America might still be bisected by the Western Interior Seaway, a shallow inland sea running from the Gulf of Mexico to the Arctic. Europe remains fragmented into archipelagos. South America, Africa, and India are already drifting, but their climates under a prolonged greenhouse would be wetter, warmer, and less seasonal. Picture a world map unlike the one we know. Inland seas shimmer, where today we see plains. Forests grow, where today there is tundra. Deserts may shrink, replaced by sprawling wetlands. If intelligence arose, its geography of expansion, migration, and trade would be shaped by waterways, not highways, by archipelagos and shallow seas rather than continental interiors. Of course, these are only trajectories. Climate is never static. Volcanism, orbital cycles, and tectonics would still reshape the planet. The Deccan Trap's eruptions, already underway before the impact, might have continued altering the atmosphere, pushing carbon dioxide even higher. Cooling events might still have punctuated the warmth. Evolution would have followed branching paths, unpredictable in detail. Yet the broad pattern remains. Without the impact, Earth likely continues as a greenhouse world, lush, humid, and ocean-rich. A planet of inland seas, swampy lowlands, and tropical forests stretching to the poles. A planet where the geography of opportunity is liquid and shifting, where civilizations, if they arose, would have grown out of archipelagos and shorelines, not vast, dry continents. And so we return to the central puzzle. In such a world, would humans ever have appeared? Or would another lineage, perhaps even a dinosaurian one, have found its way toward intelligence, guided not by fire on the plains, but by water, wetlands, and coastlines that covered the face of the earth? This is the question that lingers beneath everything. If the asteroid had missed, if the sky had remained unbroken on that day 66 million years ago, would we humans still have appeared? The simplest answer is also the most sobering. Probably not. At least, not as us, not in this form, not on this timeline. Evolution is not a straight line marching toward inevitability. It is a branching tree, full of contingencies. The mammals that eventually gave rise to primates, and from primates to humans, only found their ecological opportunity because the great reptiles were gone. In the shadow of dinosaurs, it is unlikely our ancestors would ever have expanded into the niches that allowed them to flourish. But if not us, then what? One possibility is delay. Hominins or something resembling them might have appeared millions of years later, once ecological shifts or smaller extinctions cleared new spaces. Life experiments endlessly. Intelligence may have been postponed, not prevented. Another possibility is difference. Even if primates emerged, they might not have taken the same evolutionary pathway. A different hominin lineage with different features could have carried intelligence forward. It may not have been Homo sapiens gazing at the stars, but another cousin with its own ways of thinking, speaking, and imagining. The most radical possibility is divergence. If mammals never seized the stage, perhaps another lineage might have developed complexity instead. Some paleontologists have speculated about troodontid dinosaurs, small, bird-like predators with relatively large brains and keen senses. Over tens of millions more years, could they or another lineage have moved further along the path toward tool use, communication, and even technology? We cannot know, but in the silence of deep time, such experiments seem less impossible than we once thought. This brings us to the heart of the debate. Is intelligence unique, or is it a recurring possibility wherever conditions allow? From one view, humanity is an accident, a fluke of chance extinctions, shifting climates, and evolutionary gambles that could never be repeated. From another view, intelligence is a strategy rare, but not singular. Given enough time, enough ecosystems, and enough experiments, something like it may appear again and again, though never in the same form. In this light, the question, would we be here, becomes less about certainty and more about perspective. No, perhaps not us, not Homo sapiens. But yes, perhaps another species, another lineage might have stood in our place, looking out at oceans and stars, wondering the same questions we ask now. The record is not complete. It may never be complete. But what it does show is that intelligence is not the permanent crown of evolution. It is a visitor in time, fleeting, fragile, extraordinary in its moment. If the asteroid had not struck, we would almost certainly not be here. Yet life itself would still have filled the planet, adapting, diversifying, experimenting in forms we cannot imagine. So when we ask whether humans would exist without the extinction of the dinosaurs, the honest answer is a quiet one, probably not. And yet the possibility of other minds, other civilizations, other intelligences rising in our place is enough to remind us that we are not the only story evolution could tell. We are simply the story that happened this time. As we come to the end of this long journey through deep time, it helps to pause and breathe in the scale of what we have seen. The Earth is old, it is restless. It is a world that erases almost everything that comes before. Civilizations, ecosystems, even whole lineages vanish. and what remains is never the full story, only fragments. The record is not complete. It may never be complete. Even our own chapter will not escape this rule. The monuments we build, the cities we think of as permanent, will not last. A few thousand years from now they will be dust. A few million, and almost nothing will remain. Perhaps only a thin chemical line in the rock, an odd spike in carbon, a scattering of plastics, the faintest echo of industry. That may be all that is left to tell future beings we were ever here. It is a humbling thought. If chance spared us once, if one asteroid's timing opened the door for mammals to flourish, for primates to rise, for humans to appear, then our existence is not guaranteed, but contingent. Fragile, temporary. The lesson of deep time is not only wonder, but responsibility. If we are only a moment in Earth's story, let us act like this moment matters. So tonight, as you drift into sleep, let these reflections settle gently. The silence of deep time is vast, but within it, our presence is real, however fleeting. Take comfort in the mystery and carry forward the humility it teaches. If this helped you slow down, save it and let it play again whenever you need to breathe in perspective. And if you want to explore further, the next film will ask another question. If humanity vanished today, could we detect ourselves 10 million years now? Until then, rest well. You are part of a story older and larger than you can imagine, and for this brief chapter, you are here. If dinosaurs had not fallen to the asteroid, what shape could intelligence and even civilization have taken on Earth? Some lineages were already on an evolutionary trajectory toward bigger brains. Troodontids, small, bird-like predators, had high encephalization quotients, large eyes, and grasping hands. Give them another 60 million years without interruption, and their descendants might have developed even greater cognitive complexity. Instead of primates, perhaps troodontid descendants became toolmakers, hunters with language-like calls, social hierarchies, and long memories. They might have been the reptilian equivalent of corvids and primates combined. If such beings had crossed the threshold to civilization, their world would not resemble ours. Imagine cities designed not for mammals but for reptiles, warm-blooded in part, but still tied to the Sunday. Architecture might sprawl outward instead of upward, maximizing exposure to warmth. Materials could be bone, shell, or hardened clay, shaped to withstand heat. Their culture would be shaped by different senses: sharper vision in twilight, greater sensitivity to movement, and perhaps color signaling instead of spoken words. Communication might blend vocalizations with skin patterns, language written on the body. Would reptilian intelligence reach metal and fire? Possibly, but the path might diverge. Dinosaurs had claws, talons, and beaks, but not fine, grasping hands like primates. Tools could evolve from extensions of claws, crafted harnesses, binding, or even bioengineered symbiosis with other creatures. Fire might be less central, replaced by harnessing of solar heat or geothermal vents. If such a civilization had risen 60 million years ago, where might they be now? Could they have reached the stars before humans existed? If so, traces might lie hidden, not in fossils but in chemical fingerprints, isotopic anomalies, or even artifacts buried beyond recognition. Or perhaps they destroyed themselves long before mammals inherited the Earth, another cycle lost to time. The question is not just what if dinosaurs had become intelligent, it is also what if humans are not unique. Intelligence may not be a singular miracle, but a recurring pattern emerging, vanishing, and emerging again. In this light, we see ourselves differently. We are not inevitable, not permanent. We are one branch in a tangled history of experiments. Perhaps we are only the latest, not the last.